Traditional accounting relies on flat ledgers. They capture total expenses perfectly, but when subjected to the delays of a real-world schedule, a static budget fractures. Securing $4 million for a project does not guarantee liquidity. A project can still stall if a controller cannot predict whether a specific month requires $200,000 or $2 million. Trimble Unity Construct solves this temporal mismatch through its cash flow cost entity. In this system, cash flow acts as a predictive financial model. It calculates the exact amount of capital required each month over the remaining life of a project. Building an accurate forecast requires 3 distinct steps. First, the software must establish your absolute current budget and all projected commitments. Second, those financial commitments must be explicitly mapped to real-world schedule tasks. And third, mathematical distribution algorithms are applied to simulate how construction capital actually burns over time. By linking static ledgers to calendar tasks and expenditure curves, the platform generates an actionable timeline of capital needs from a formerly isolated list of costs. The starting point for valid projections is calculating current totals on the Quick Cost Summary dashboard. Looking at the Quick Cost Summary, we begin with the current budget. This combines the original approved budget with all formally approved changes. To calculate expected spend, current commitments adds your original commitments to approved commitment changes and general invoices. Note how the software handles available funds. Cash is only depleted from a funding source when invoices are formally approved. The system completely ignores invoices that are merely marked as received. These figures establish your core metric, the estimate at completion, or EAC. This represents the total projected cost to finish the work. The EAC equals projected commitments, forecasted commitments, and unallocated reserve. The difference between your EAC and projected budget produces the forecasted over-under metric. A positive variance indicates the project is currently over budget. A 0 or negative value means you are hitting or beating your financial targets. If your initial EAC and commitment values are incorrectly calculated, any subsequent time-based distribution model will simply forecast the wrong final numbers. Once the static numbers are validated, you must map those costs onto a calendar. This setup occurs on the Setup Cash Flow page. Here, you allocate your remaining project money against specific time constraints. You manage these constraints using the Schedule link type. This dictates the exact months a budget line item is permitted to draw cash. The Link to Schedule option broadly spreads the cash flow curve across the start and finish dates of the entire project. Conversely, Link to Tasks isolates costs to a specific phase. By strictly tying a cost to the construction phase's start and finish dates, you prevent capital from being prematurely allocated during the design process. A third option, Link to Project, maps costs to overarching target dates that operate independently of the formal task schedule. Depending on the nature of the line item, these vastly different duration boundaries ensure capital is reserved strictly when required. By tethering a budget directly to the task schedule, any physical delay in the work automatically shifts the forecasted capital requirement, preserving accuracy. Establishing a time frame sets boundaries, but capital is rarely spent in perfectly even increments. To address this, the cash flow curve dropdown lets you apply specific mathematical distribution algorithms to individual budget line items. The manual approach allows you to input exact monthly amounts. This is ideal for discrete, one-time expenses, like permits, which lack a natural distribution curve. The linear curve forces an equal allocation of money into each month. It is perfectly suited for steady-state expenses, like support staff payroll. For complex spending behavior, this chart illustrates the inverse S-curve, where a massive initial allocation of funds is calculated upfront before rapidly declining. You assign this curve to project inception expenses, such as initial design fees that demand heavy capital early on. Even with perfect algorithmic distribution, a hidden real-world variable disrupts the model, the physical delay of check processing and accounts payable. The payment lag setting solves this. It extends the cash flow timeline past the formal end dates of a linked task to reflect when the cash physically leaves the treasury. As you configure these timelines, the software enforces a strict cutoff. All current month updates must be finalized before exactly 11:59 p.m. Coordinated Universal Time on the last day of the month. Local time zones are overwritten. Applying tailored distribution curves and realistic payment lags bridges the gap between theoretical project scheduling and the physical reality of corporate banking constraints. When you aggregate dozens of S-curves, linear distributions, and payment lags across an entire ledger, they merge into one massive master projection. The Recalculate All function automatically processes every applied curve and schedule link into this unified timeline. The direct benefit to the financial controller is absolute clarity. You can definitively view the exact funds sitting in the Remaining to be Allocated column for any approaching month. The Previous Cash Flows view allows you to audit historical months, tracking your actual approved costs directly against your past projections. The final, most critical step of the entire configuration workflow is executing the Save Baseline command. Saving a baseline permanently locks the initial optimized cash flow model to serve as the comparative standard for the remainder of the project. Without a locked baseline, future schedule slips or budget overruns cannot be mathematically audited against the team's original expectations. The complete process requires discipline. Static budgets determine the estimate at completion. Those totals are tethered to temporal tasks, and algorithms dictate the monthly burn rate. By systematically modeling time, tasks, and expenditure behavior, Trimble Unity Construct provides the oversight needed to align treasury reserves with actual project demand.